Okay, good morning, children. Uh, Today we are having this topic. It is assigning oxidation number of elements in a species. Suppose HCl. Let us consider first HCl. Uh, we know oxidation number of HCl. We have discussed of HCl it is plus 1, and of Cl it is minus 1. Because uh, when we imagine this HCl molecule to be separated, then it becomes H plus and Cl minus. There occurs a heterolytic fission, and the pair of electron comes onto chlorine. That's why it becomes Cl minus, and H becomes H plus. And we say oxidation number of hydrogen is plus 1 here, and chlorine it is minus 1 here. In this way, the oxidation number of hydrogen in water it is plus 1, and oxygen it is minus 2. Now there are certain guidelines you will find in your NCERT book. There are guidelines by which we can easily assign oxidation number to elements in a species. Like according to the guideline, hydrogen always has oxidation number of plus 1. Hydrogen has oxidation number of plus 1. Of course, if it is attached to alkali metal, then it will have a minus 1. For example, say this compound, calcium hydride. This is calcium hydride. Here hydrogen is not plus 1. Here hydrogen is minus 1. And calcium is plus 2. Calcium is plus 2. So in hydride where hydrogen is attached to metal, their oxidation number of hydrogen is minus 1. Otherwise, oxidation number of hydrogen, it is plus 1. That you have to remember. Suppose ammonia, oxidation number of hydrogen as before plus 1, and then how much will be of nitrogen, that we can calculate in this way. Suppose if we know one element and we have to calculate the other element, that we can do in this way. Hydrogen is one we know, so let nitrogen be X. So X plus 3 into plus 1 equal to, and since it is a molecule, overall sum will be 0. So X plus 3 equal to 0, so X will be equal to minus 3. So oxidation number of nitrogen here is minus 3. So what we have seen here is that hydrogen oxidation number is plus 1, but in case of hydrides, like calcium hydride or potassium hydride or sodium hydride, here hydrogen has oxidation number minus 1. Now generally group 1 elements in the periodic table, they have oxidation number of plus 1. Group 2 elements have oxidation number of plus 2. In group 1 we have hydrogen, lithium, sodium, potassium, cesium, francium. These all elements have oxidation number of plus 1. Then say beryllium, calcium, magnesium, strontium, they all have oxidation number of your +2. Suppose we have group 16 elements. Group 16 elements where we have oxygen, sulfur, selenium, tellurium, polonium. Polonium, their very common oxidation number is -2. You have to remember, it is -2. Like oxygen, it is -2. Like there we have already used. So these elements, in general, they have oxidation number of -2. Why -2? Because group 16 elements. Group 16 elements, they have general electronic configuration NH2, NP4. The elements of group 16 have general electronic configuration NH2, NP4. So they have 4 plus 2, 6 electrons in the outermost shell. 6 electrons in the outermost shell. So their oxidation number -2 comes out 8 minus 6. 8 minus 6. How much? 2. 2. And why it is -2? Because they are electronegative elements. That's why it is -2. Similarly, you can now say group 17 elements. Group 17 elements where we have fluorine, bromine, iodine, and astatine. Group 17 elements, they have general electronic configuration NH2, NP5. They have general electronic configuration NH2, NP5, so that they have 7 electrons in the outermost shell. 7 electrons in the outermost shell. So they have oxidation number of 8 minus 7, 1. And since they are electronegative, so they have oxidation number of -1. So these are common guidelines. Alkali metal, they have +1. Alkaline earth metal, group 2 element, they have +2. Group 16 elements, they have -2. Group 15 elements, where you have nitrogen, phosphorus, arsenic, antimony, bismuth, they have -3. They have -3 oxidation number. So you see, that's why nitrogen here you see is -3. So you see nitrogen here in ammonia, it has come out to be -3. So let us find out. Suppose you may get question. Calculate the oxidation number of underlying element. Underlying element. Suppose here Mn is underlined. So you are asked to calculate the oxidation number of Mn. So what we will do, we will first say let the oxidation number of Mn be X. So let oxidation number of Mn be X. So it will be like this. K is a group 1 element. So K will be +1. Plus Mn, we don't know, X. Plus oxygen, we know oxygen, it is -2. Then oxygen is -2. So we have added all the oxidation number, and their sum will be equal to 0. So it's a compound, neutral. Okay, so we have next step, X, 1 plus X minus 8 equal to 0. So X minus 7 equal to 0. X is equal to +7. So oxidation number of Mn in Chem 4, it is plus 7. Now you may be asked to find oxidation number in a positive species or negative species. Say one example is here. Suppose you are asked to find oxidation number of nitrogen in NH4 plus. So it will be like this. Again, nitrogen, suppose it is x plus 4 into 1. Hydrogen, is plus 1. And since overall charge here it is plus means plus 1. So here we have to write equal to plus 1. Here we won't write 0 because it is a positive species. So x plus 4 equal to 1. X into 1 minus 4 equal to minus 3. So oxidation number of nitrogen in NH4 plus it is your minus 3. Now let me tell you regarding oxidation number of oxygen. Oxidation number is minus 2. This is most common. Oxidation number is minus 2. But suppose a compound, say H2O2. H2O2 is hydrogen peroxide, and its structure is HOOH. Hydrogen peroxide is this, and we call this oxygen linked with oxygen. Such oxygen is called peroxide oxygen. This is a peroxide oxygen. Peroxide oxygen has oxidation number of minus 1. That you have to remember. Normal oxygen is minus 2, but if there is peroxide oxygen, it is minus 1. That you have to remember. So oxygen has oxidation number minus 2, peroxide oxygen minus 1. Now the question arises, can oxygen have your positive oxidation number? Can oxygen has positive oxidation number? Yes, that also is there. For example, if you have a compound, say OF2, and if you are asked to calculate oxidation number of oxygen here, then it will be like this: X plus. Now fluorine, which is an element of group 17. Fluorine, is the most electronegative element. There is no element more electronegative than fluorine. So fluorine will have oxidation number minus 1. So 2 into minus 1 equal to 0. So x minus 2 equal to 0. X is equal to plus 2. So in OF2, oxidation number of oxygen is plus 2. So now in the same way, you can calculate oxidation number of chromium. Chromium you can calculate. I am telling you the answer. You have to work out in this way. Chromium, it will come out to be plus 6. Chromium, it will come out to be plus 6. Okay. One very important thing, let me tell you, is group oxidation state. What is group oxidation state? Suppose group 1 elements, they have electronic configuration, they have general electronic configuration, it is NS1. they have outermost electronic configuration NS1. They have one electron in the outermost shell. They have only one electron in the outermost shell. So they, that's why we have already written their oxidation number is +1. They have oxidation number +1. Now, as we have seen here, oxygen can have oxidation number -2. It can also have oxidation number -1 in case of peroxide. In some cases, it can also have oxidation number +2. An element can have variable oxidation number. It depends on it is attached to which other elements. So now an element can have variable oxidation state, but group 1 elements, there is a term called group oxidation state or the maximum oxidation state. The group 1 elements, they have maximum oxidation state or group 1 or group oxidation state +1. They cannot have oxidation state more than +1. Their highest oxidation state is +1. Say group 2, they have highest oxidation state of +2. Like group 15 elements whose general electronic configuration is NS2 NP3. They have 5 electrons in the outermost shell. So group 15 elements, they have their group oxidation state or maximum oxidation state +5. They cannot have, in any compound, in any species, they cannot have more than +5. +5 is the highest. Okay, they have their common oxidation state as said before -3. They can have -3, but their maximum oxidation state is +5. It cannot be more than +5. So tell me then, what is the group oxidation state of group 16 elements? What is the group oxidation state of group 17 elements? So group 16 elements, where the general configuration is NS2 and P4, their group oxidation state will be +6. This oxidation state will be +7. Okay, now let us do now the last case here. Last case here for today. CrO5. Okay, now you see, if you consider CrO5, if you calculate, then X plus 5 into, suppose you are asked to find your chromium, 5 into oxygen is -2, 0, so X minus 10 equal to 0, X is coming to be +10. But chromium, chromium position in the periodic table, you will see chromium is present in group 6 of the periodic table. Chromium is present in group 6 of the periodic table, and chromium has group oxidation state +6. Highest oxidation state +6. Now here we are getting it to be +10. So you see this value is wrong. This value is wrong. So chromium, an element of group 6, has highest oxidation state of +6, but here on calculation we are getting +10, so this is wrong. So what is the correct oxidation state of chromium? Correct oxidation of chromium, you have to, for this case, you have to know its structure. The structure of CrO5, it is like this. This is the structure of CrO5, and you see this is peroxide oxygen. It is -1. It's not -2. This is peroxide oxygen -1. This is peroxide oxygen -1. This is peroxide oxygen -1. This is normal oxygen. It's -2. So what is the total negative charge we got? -1, -1, -1, -1, -2. So -6. -6, so chromium will be +6. So in CrO5, oxidation state of chromium is +6. So in such cases you have to know their structure. So children, this much for now. In our next video we will be doing most important topic of this chapter, that is balancing redox reaction.